Okay, so let's continue with our Python interview questions. So this is question number 7. So one second. Yeah. So this is question number 7, and the question like so many times even I observe most of the time interviewer asked, do you know like what is GIL in Python? And if you know, kindly explain. And maybe sometimes with example as well. So what is the GIL in Python? So we are going to look at this. So the full form of the GIL is the Global Interpreter Lock. So so this is kind of a lock. But what exactly GIL is and what it is relation with the Python? So GIL is basically a concept. It is a concept related to the programming language. It is not only specific to the Python. This concept is not something you can't say like this concept is only specific to the Python. This concept is specific to the programming language, right? So this GIL concept is in many programming language. As an example, in Python we have the concept of the GIL. In the Ruby we also has the concept of the GIL. So you can't say GIL is only the concept of the Python. No, GIL is the concept of the programming language, right? And it can be for the many programming languages. Example, Python and the Ruby. The both have the GIL concept. Okay, what exactly the GIL is? GIL is. So before understanding the GIL, we have to look at this how our when we run our Python code, how it works. So we have the CPU, right? And when we install Python, so we have the Python interpreter in this diagram. Let me zoom it. Yeah. So we have the we have the CPU, we have the machine. In the machine, we have the CPU, and we have the Python interpreter. Okay. So we can run many processes. Many processes means like many Python code. Maybe there is a one script, dummy.py. This is the another script, dummy2.py. So a multiple process can be run. All right. And one process, like we can implement multi-threading as well. Like, so you can write in any programming language. I'm not talking about the Python programming language. In any programming language you can use the concept of the thread. So thread is basically the smallest unit of the process. Correct. So you can this red symbol, you can see a thread. So this, let's suppose the process one has three threads, process two has the three threads. Right. So basically why we are using threads to make to make the program run faster basically. Because if there is only one process and one thread, then only that thread has to do the work. So as an example, you can consider if there is one person and he has to do all the work. If there are three-person, and the whole work will be divided into three uh, three tasks. Okay. So how, like, let's suppose you write some Python code, right? And you write your Python code in some in terms of threads. You use the basically the concept of the multi-threading. So you write Python code, you use basically three thread, thread one, thread two, thread three. You started the three thread, and you within the code you tell thread one you have to do this task. Thread two you have to do this task. Thread three you have to like this task. And why we are using threads? So that our code, like, instead of completing in, let's suppose, 5 minutes, it should complete in 1 minute, or maybe like 3 minutes or 2 minutes. All right. So but what will happen in the Python? We design our code in such a way it should run faster. But did it actually run faster? So the answer is no. So in the Python, the answer is no for the CPU bound task. So I will explain with the Python code example, like what is CPU bound task and all these things. So as an example, so whenever Python code runs, so we in the Python code we say thread one dot start, thread two dot start, thread three dot start. So all this will go to the Python interpreter. So the code will, because where the Python code is going to be run on the Python interpreter, right? So all the code will go to the Python interpreter. And within the Python interpreter, so there is a GIL. There is a concept of the global interpreter log. So what it will do is, it will, if one thread is running now, right? If one thread is running, it put the log. So it put the log. So the other two threads are not going to be run. So basically, we are expecting we write our Python code so that it should run faster. We created threads, but at the Python level and at the back end, at the interpreter level, the GIL put the log and only one thread at a run at a one time. Then why we are writing three threads? So why can't we just write one thread? Why we are making our code even more complicated, even use the threading, multi-threading concepts, right? That is perfectly fine. So GIL is basically what it did is it allows only one thread to execute at the interpreter at a time. So this concept for the Python and the Ruby, and it could be for many other language. So basically it operates at the thread level. Okay, so basically uh, in the in general terms, we have the process and with the thread. So whenever two process run, so let's suppose you run one Python code here and one Python code here. So when two, so this process has their own memory, has their own variables, has their own shared space, has everything. So this process has their own, like whenever process is going to run, it allocated some memory, it allocated some variables, everything is going to be in their space. When the process 2 is going to be run, everything is in their own space. So process 1 is not going to the process 2 space, and process 2 is not going to the process 1 space. But when the concept of the threading come now, so threads are within that process. So let's suppose I run one program. As soon as I run program, it allocates some space. All right. So this box is called as a some space. So let me. So this. Okay. 1 second. So this box, like this small box where I written process one, this box is some like space allocated to that, and whatever the thing is going to be used, like allocate the memory, allocate the assign the variables within that space. But threads are running in this. So if one thread is run, it is going to be use this space only. If the second thread is going to be run, it is also going to be you consume the same space only. If the third thread is going to be run, it is also going to be consume the same space only, right? So there are chances of the data corruption. There are chances of data corruption, right? Because one thread is also like doing the task in this memory space. At the same time, the second thread is also going to be do the same task in the same memory space. So Python, like earlier assume there could be the chances of data corruption, right? So or maybe like you have heard the term like race condition, right? So there are chances. So it we can't say like like there is a only the disadvantage of the global interpreter law. Yes, there is a disadvantage of the global interpreter law because we want to run three threads, and at the back end only one thread is running. So our Python program code is like running slowly. But the advantage is simplified memory management means, as I told you, whenever one process is going to run, it is going to allocate one memory space, right? So if one memory space, we even though created three threads, but at the interpreter level, two threads are going to be locked, only one thread is going to be running. So if one thread is going to be running, it is only going to use that memory, it is going to use that variables. So when that going to be finished, then other thread is going to be run. So it is basically simplified the memory management. And this GIL concept, we can't say like, even though there is a concept of the multi-threading, now the question might arise. Now I am saying there is a concept of the GIL. GIL means global interpreter log. What it did is, right, it like put the logs on the thread, and only one thread run at a time. Then why like Python introduced the concept of the threading? What is the use of that? So basically, GIL concept mainly impacts the performance for the CPU bound task, not the network or input output bound task. So what is the CPU bound task, or what is the network or input output bound task? So CPU bound task is, let's suppose you write some Python code, uh, a, a very huge array. Let's suppose a list of 100 elements or 100 integer or 100 floats, right? Now I told you write a Python code to sum all the 100 elements in a list or array. So that computation is going to be performed on the CPU level. right? So you are going to do the addition or subtraction, whatever you are going to do, that computation is going to do on the CPU level. So that is the CPU bound task. So if you try to run the multi-threading on that CPU bound task, I am going to show you the example with Python code. Then due to the GIL, you are not going to see the performance impact, right? But if there is a network or input output bound task, let's suppose if I gave you a list, and in the list, as an example, if I gave you list, and in the example there are like 10 website. So website 1, website 2, website 3, website 4, four website. And if I told you to scrap all the website, or maybe download one image from all these website, then one approach is this: you just run a loop, and you are just going to then go to the first website, download the image, then go to the second website, download the image, then go to the third website, download the image, then go to the fourth website, download the image. But if you see, all these are the different website. So here, if I use the concept of the multi-threading, na, it's going to be work. Then the GIL concept is not come into the picture, because when I run, let's suppose I created two threads. So first thread will work on this website and one website 2, and the second thread is going to work on the website 3 and the website 4. So when my first thread is running, so the GIL put the lock. Yes, GIL definitely GIL going to put the lock. But when I go to the website, so that is not a CPU bound task. That is a network. I go to some other server, right? So my CPU is free. So if CPU is free, the GIL will release this thread. So as soon as GIL will release this thread, my this thread will start working. Now I am going to get this output within a microsecond, or maybe within some second. I am going to get this output. So as soon as I get this output, again this thread start running. So this thread will get stopped, or maybe hold, or by using the GIL. So GIL is the global interpreter log. It is a concept of the programming language. It operates on the thread level, not the process level. So basically this process has one GIL, this process has another GIL, you can say like that, right? So it allows only one thread to execute at the interpreter level, and this mainly impacts CPU bound task, right? So there are two languages, Python and the Ruby, which has the GIL concept. So let's look actually how the GIL is work. So I created one simple program, because I told you GIL will mainly impacts on the CPU bound task. So let's see whether really or it just is a term, or whether it's actually going to impact. Right, so this CPU bound task means some kind of operation, minus operation or plus operation. So what I did is, uh, I just created a one function, and what this function is going to do is, it is just going to do some counting in a reverse order. So this is a very huge number. I don't know, like it's a 5 crore or 50 crore. So this is a very huge number. What it going to do? It is going to be count. So how to going to count until this number is, while this number greater than zero, do minus, and once it's going to be zero, it's going to be finish. So before starting, I calculate the start time, and once I call this function, after that I calculate the end time, and then I am calculating the end time minus start time. So let's run that. So Python testing dot, sorry, I run some other program. So now it will wait, because the number is very huge. So let's see how much time it will took, because I am running as a single thread. Because in this, if you observe, I am not using any from threading, from multi-threading, more threading. I'm not using any kind of concept. All right. So this is just a single thread, and it is a CPU bound task. So if you observe, it took 20 seconds, approximately 20 seconds it took. Right. So okay, now I told you Python has the GIL concept, and it is going to put the log. Does it really going to put the log? Let's see, does it really going to put the log? So what I want is, because it is a very huge number, what I want is, like, I am not aware like whether the Python has a GIL or not. Let's assume. what I want is I want to implement the concept of threading. So let's write some other code. The code is already being written. Let me uncomment. So what I'm doing is I am like use this. I am basically I have to call the same function. I have to call the same function, but now these function will be run by two, like you can say, two threads. So how the two threads? So basically I have to count. Basically I have to count this number of times. So what I will do is, let's divide this, and let's suppose I have to count by till 100, right? So I am the single person. If I call 1 2 3 4 by 100, it will take some time. If there are two-person, and I called, I assign, okay, person one, can you call 1 to 50, and person two, can you call another 1 to 50, and total is like 200. So this is the same concept of the threading. So thread one will uh, count half of the work, will do half of the work. Thread two will do the half of the work. So basically what we did is, so we create two threads, T1 and T2. We create two threads. In the thread, which function we are going to like run? Target means which function we are going to run. This count function. Okay, how much count? So I can't pass the whole number, because I have to divide the work within the thread. If I pass the whole work, then there is no use. If I'm using threading, I have to divide the work. So to the first thread, I said, okay, do half of the work. On the second thread, I said, do half of the work. Argument means, earlier I am passing this whole number, now I am passing divided by 2. Okay, now, so this just a thread is created, but the thread did not start. So before starting the thread, I calculated the start time, and then I started the thread, I joined the thread, and then I calculated the end time. Now let's see. Now I have uncommented both the code. Let's see, is there any impact? Is there any impact? Because this code is being run in 20 seconds. Now I am running two threads. So I am expecting this code should run in 10 seconds. So I am expecting this code should run in 10 seconds. But this is really going to run in 10 seconds. So let's see. So let's see. Definitely it's not going to be run in 10 seconds, because the concept of the GIL, Global Interpreter Law. But we are going to see in the practically. So just wait a couple of seconds, because the first code, that is the without threading, it took, yeah, it's completed, and it took 20 seconds, which is fine. We already see that this code took 20 seconds. But now we use two threads, and we are expecting half of work, and both the thread is going to be in parallel. So 10 second, 10 second, approximately 10 or 11 seconds. We are expecting this code should be completed in the 11 seconds. But if you see, this code is not completed in the 10 or 11 second, even though it's completed approximately the same time, 20 second and 20 second, same time. Why this happen? Even though I use thread, why this is happen? This is because of the global interpreter lock. Because even though I created two threads, as soon as the first thread started, second thread put on the lock. Because I am running the Python code, and the Python interpret put the lock. So because of the GIL concept, it put the lock. So if one thread is, only one thread is running, and the one thread is a lock, then this work completed in 10 seconds. This work again complete 10 seconds. So 10 plus 10, 20 seconds. So again, I'm taking the same time only. So that's why multi-threading or threading concept is not useful in Python for the CPU bound task. Only for the CPU bound task, but it is the network bound task, or input output. Input output means like you are writing on some memory hard disk. If there is input output bound task, then the multi-threading is useful. But if you have the CPU bound task, then multi-threading is not useful. Sometimes people ask, okay, I have this Python code, can you improve the performance by using the multi-threading? So you have to see the first logic, whether this is the CPU bound task. If the CPU bound task, you have to directly say to no. Even though you are going to use the multi-threading, this is not going to increase the performance because of the GIL concept in the Python. So this question is going to be asked many number of times in the Python. So you should aware what is GIL, how it is going to work. So first, basically, what is GIL? Tell me. then mainly thing is like that it will work on the CPU, like it impact the CPU bound task or the network bound task. So the answer is CPU bound task, and we see in the example as well. So that's it. That's the end of the video. Thank you.